Welcome guys to this sessions. Today I bring a new set of challenge as a part 2 for you guys. So this challenge contains three sets of questions have its own difficulties level. So you should have to read the questions very carefully, and when you did the lab you have to monitor it as well that you did it in the correct way. So let's go to the first challenge. So this is the challenge number 1. Create a new deployment called Web 003. Scale the deployment to 3 replicas. Make sure desired number of pods always running. So this looks to be a very simple questions, so that it's asking to create a deployment having the 3 replicas, and the replica handle the pods. So whenever the desired pods is not get meet, it's create another one. So whenever the one pod get destroyed, the replica set responsibility to bring it up. So this looks to me a very simple, but if you see the weightage of the question, it's at 7%. So there might be some problem that going to face we are going to face in the environment. So we have to look into it. But as per the current understanding, this is not simple as it looks in a first glance. And this is the similar questions that was asked in my CKA exam. That's why I put it in this set of challenges. So let's go to the hands-on to look into how we are going to create a deployment. Okay, as per the questions, we have to create a deployment. So let's create it. So CTL create deployment. The name of the deployment is Web 003, and we have to use the image as per the question. We can use any image as we require. This is not mentioned in the question, so let's take it as a Nginx. Replica as per the question is 3. So we created a deployment with 3 replica. Let's wait for a few more minutes. The current available pod is 0. So out of the 3 pods, none of the pod is available. So it looks something problem. So we have to think about that which master component is responsible to managing the replications related things. It's a controller manager which handle to manage all the pods, and whenever the pods get down, it's create another pod, and the pod that is related with the master cluster component exists in the cube system namespace. So let's monitor the cube CTL and cube system namespace get pod. So you can see that the cube controller manager control component it's not working properly. So we have to find the reason behind it, how to find why it's not working, because this is the component which bringing the pods and managing the pods, the desired pods as per the replica we provided. kubectl kube system logs for kube controller. I'm checking the logs of the kube controller. We don't have any informations. Okay, so let's describe it. kubectl, just first use the namespace kube system describe pod kube controller. So it looks that we have some problem and we need to identify what is that problem. It looks to me that the kube controller, the word is not perfect. It should be manager here. Kube controller manager. So let's clear the screen. We know that this all things managed by the static pod. So, and we know the locations where it's kept. So if you don't know the locations, we can identify that as well. But let's check in the etcd Kubernetes manifest file first. Kubernetes manifest. And this, okay, so all the static pod have the configurations file in this location. So let's look into the kube controller. We have to look for the word MAM. Okay, it's in the beginning. So you can see that there is some mistake that occurs here. So we need to modify that particular thing, manager. So that's it. I think it will work now. Let's watch for the simple, we can say kubectl get deployment it's look like the pod is not bringing up. Okay, let's watch it. kubectl get deployment. So let's wait for a few more seconds and probably it will be working fine. The problem we had seen is already fixed, so I think it will work. Okay, now you can see that the pod getting created. Okay, let's press Control C, come out from the watch, kubectl get pod. So you have all the pods running. kubectl get deployment. So the deployment is working fine. So whenever if you see a simple question in the exam, so that you have a clear understanding, okay, this one is simple, just look into the weightage as well. If the question have the high weightage, means that there is some problem. So you have to be very careful in the exam. You have to monitor it. It's not that you create a deployment and just jump into the next question. You have to review either the pod is gets created or not. So because this is a high weightage questions, and you have to put some time on this to just make sure that whatever you did is correct. Okay, this is the challenge number 2. We have to upgrade a cluster, the master and the worker node, from 1.18 to 1.19. Make sure to first drain both the node and make it available after the upgrade. So this is the straightforward questions that we have to do: upgrade the cluster, the worker also, and the master worker and the master both the nodes. And the revision is 1.18 to 1.19. First we have to drain, use the drain for the master, and then we have to deploy it, upgrade our cluster, and again after doing the upgradations we have to uncordon that node. The similar way we have to perform the same activity for the worker node as well. These questions have the weightage of 11. So you have to do or perform all the activities for the upgradation very carefully, and this similar way we can check it as well. So let's move to the hands-on for the challenge number 2. Okay, the main agenda for today lab session is to upgrade the master node and the worker node from 1.18 to 1.19 version. So before doing that, let's monitor the environment first. Kubectl get node. So you can see that the master and the worker node both have the version of 1.18. So let's drain the master node first. Kubectl drain control plane, and we need to pass one more command to ignore daemon set. Okay, let's start draining the master node. So it's evicting all the pods. So if you look into the same command again, kubectl get node, so you can see that the scheduling is not disabled for the master node. And if you see the kubectl get pod, how many pods we have, so you find all the pods in the node 1. Not you will not find any pod for that is running. So we have only one pod that is running. And for this, if you want go for the wide options, you can find it in this is currently deployed on node 01. So let's start the upgrade process. So first apt update. Okay, so now install apt install kubeadm, and the version is 1.19.0-0. Okay, this is the version we have to upgrade. Say why, yes, go for it. So kubeadm is now upgraded. So you can check the version also, and the version is also already provided here that it's upgraded to 1.19. Now kubeadm apply upgrade apply. Apply to version 1.19.0. Sorry, apply, that's spelling mistake. So it will take a little time, 1 to 2 minutes, for this to just pull all the images for this deployment. So we have to wait till it get executed. Perfect. So you have the message that your cluster was now upgraded to 1.19. Now our main task is to upgrade install the latest one for the kubelet as well. Apt install kubelet 1.19.0. Okay, restart the kubelet system. CTL restart kubelet. Okay, it's started. Now check the just clear the screen first. Kubectl get node. So you find that the master node now upgraded to 1.19. Now uncordon it, so it will be ready for work. Kubectl uncordon control plane component. Okay, kubectl get node. So now it's ready for any kind of deployment into the master. Now it's time for the node one. Kubectl drain node 01. Ignore demand sets. So now it's evicting all the pods whichever we have in the deployed on the node 1 to the control plane component. kubectl get pod O of wide. So you find that the same pod which is previously running on the node 01, it's now running on the control plane node. So we moved it because we have to manage the cluster. We have to upgrade the worker node. So it's now drained. So kubectl, you can check it. Kubectl get node. Now it's not ready for work. For node 1 is now in the draining position. Scheduling is disabled. Now SSH into the node 1 because we need to upgrade the cluster worker node. Apt update apt install kubeatm kubeatm is equal to 1.19. This is a version for which we are going to update. Yes. Okay, now clear the screen. kubeatm upgrade node. Okay, now the node has been upgraded with the kubeatm apt. For the kubelet, we need to install the latest one. Apt install kubelet is equal to what is the version? 1.19.0/00. Okay, now restart the kubelet, same as we did for previously for the master. System ctl restart kubelet. Okay, so now currently we are in the node 1 worker node. So we have to come back, press Ctrl D to come out from the worker node. Ctl get node. Okay, so you can find that both the master and the worker node have the version of 1.19, but one thing is left, that we need to uncoordinate the node 1 because it's not ready yet for any kind of deployment. For this, kubectl uncoordinate node 01. Okay, now check the status again for the node. Okay, so the control plane component, the master cluster and the worker node both are now have the version of 1.19. So now the upgrade is finished. Now the challenge number 3. These questions have the weightage of 4%. We have to deploy a pod. The name of the pod is webload 5461. We have to use a Nginx. The tag is 1.17 for the image, and we have to set a label as well. Tag is equal to web. So this will be going to a very simple questions, and the weightage is very low. So there is no trick involved or no complexity involved in these particular questions. So let's put the hands on to create a pod as per the requirement. Okay, this is the third challenge and the very easiest one with the low weightage. So we have to create a pod. Let's create it. kubectl run. The name of the pod should be web. Load, and the number is 5461. Okay, this is the name of the pod. We have to use the image for it. Nginx, the tag is 1.7. Okay. We have to put the label as well. So we are using the imperative way to do it in a faster way, because in the exam there is time constraint and we have to do it in a fastest way. So now the replicas, not labels. The label that is asked is tier web. So pod is gets created. Let's verify it. Kubectl get pod. So one pod is currently running in the environment. kubectl get pod, check for the label. So labels. So okay, the one pod is getting created, which is running, having one container, and the label is perfectly fine. So this have the lowest you can say the weightage, and in the similar way they can ask you to do this stuff in a particular cluster, in a particular using the particular namespace. So that's it. So questions having the 4% of weightage, having you have to do the similar kinds of stuff. Either you have to create a secrets using the pods, either you have to create a config map using the pods. So 4% have questions having the 4% of weightage have the similar types of questions. Thank you for watching this session. If you like my video, please subscribe this channel and click on the bell icon and share it with your friends as well. Thank you and keep learning. Have a nice day.